Let us start with looking at a risk-neutral news vendor. We will first ask the question, what quantity maximizes the news vendor's expected utility? One way to answer this question is just to calculate the expected utility, or in this case, the expected profits that are associated with the different order quantities. First, observe that order quantities below 10 units make no sense, because ordering 10 units dominates all these order quantities, and also ordering more than 13 units makes no sense, because you will never sell more than 13 units. So here we can just calculate the expected profits for ordering 10, 11, 12 or 13 units. So let us start. What is the expected profit when ordering 10 units? When I order 10 units, I know that the demand will always be at least 10 units. This means I will always sell all 10 units at a price of 10. And of course, I have to pay for these units, and I have to pay $4 for each unit, which means if I order 10 units, I'm sure to make a profit of 60. If I order 11 units, then in 30% of the cases, I will have a demand which is equal to 10. In this case, I will sell 10 units at a price of 10, and I have to pay for 11 units a price of 4. I can't return unsold units. With a probability of 0.7, the demand will be 12 or larger. In this case, I will sell all my 11 units at a price of 10, and I will again have to pay for each of this unit a price of $4 each. So let us summarize it. This is 0.3 times 100 minus 44, which is 56, plus 0.7 times 110 minus 44, which is just 66. All right. Adding these two numbers up, we get a profit or an expected profit of 63. Now let us do the same for an order quantity of 12. If I order 12 units, again with a probability of 0.3, the demand will only be 10. In this case, I will sell 10 units at a price of 10, but of course I have to pay for all 12 units. With a probability of 0.7, the demand will be 12 or larger, meaning I will sell 12 units at a price of 10, and I have to pay a price of 4 for all these 12 units. So in this case, we have 0.3 times 100 minus 48, which is 52, plus 0.7 times 120 minus 48, which is 72. Calculating it, we get an expected profit of 66. Now, the last calculation we have to make is to calculate the expected profit when ordering 13 units. When ordering 13 units, 3 different cases can occur. First, with a probability of 0.3, the demand will be 10. In this case, I sell 10 units at a price of 10, but I have to pay for 13 units a price of 4. With a probability of 0.5, the demand is 12. In this case, I will sell 12 units at a price of 10 and have to pay for 13 units a price of 4. With a probability of 0.2, there will be a demand of 13, which means I will sell 13 units if I ordered 13 units. And again, I have to pay for all these 13 units. This means in this first case, I have a profit of 100 minus 4 times 13. 4 times 13 is 52. This means my profit is 48. With a probability of 0.5, I will sell 12 units, which results in a revenue of 120. Again, I have costs of 52, which means I make a profit of 68. And with probability of 0.2, I sell 13 units, resulting in a revenue of 130 minus my expenses of 52, meaning 78. So here we have a profit of 64. Comparing all these profits, we find that the utility or the expected profit is maximized with an order quantity of 12. Now we want to ask the question if there's a faster, an easier way to calculate the expected profit maximizing quantity. And there is one. You can just look at the probability of selling an additional unit. So for all numbers between 0 and 10, they are sold with a probability of 100%. This means the expected revenue is just 10 and you have to pay 4. So it's always optimal to buy more if you are currently ordering between 0 and 10. What is the expected probability of selling the 11th or 12th unit? So for the 11th and 12th unit, the probability of selling it is just 70%. Which means you have an expected revenue for each of these units of 0.7 times 10, which is 7, which is larger than 4. So it makes sense to order 12 units, because up to then, each additional unit is increasing your expected profit. Now the question is, what is the probability of selling the 13th unit? So as you can see, the 13th unit will only be sold with a probability of 20%. And 20% times 10 is just 2, which is smaller than 4. So it makes no sense ordering more than 12 units. I mean, you could also look at the probability of selling 14 or more units, and you see that the probability of selling more than 14 units is just, or 14 or more units is just 0, which means it makes no sense to sell. Sorry, here it's of course a 4. Meaning that here you can see that up to this point it's optimal to order more. 12 is the 12th unit is the last unit which results in a positive expected profit. So ordering up to 12 units is optimal. In the next units, we will not be able to apply this shortcut, but have to go with the calculation of the utilities that, or expected utilities that are associated with the different order quantities.